Hello, my dear student. I'm Saktwala from Educare. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion for our topic of rotation of rigged boards. For the subtopic of the talk of a rotating of a rigged board. That is what we are going to look for our today discussion. So before we proceed with our discussion here, we are supposed to remember where we ended on the last session. On the last session, we tried to demonstrate the way we can find the accelerations when we have the cylinder and also the sphere. That is what we tried to demonstrate. So for our today discussion here, we are going to look about the linear acceleration of a rolling object. Imagine we have the object, and we have the rigged body. And that rigged body, my dear student, is located on an inclined plane at the top of the inclined plane. And they are being rolling. They are rolling on an inclined plane toward at the bottom of that inclined plane at the certain height. So, what is the how acceleration could that rigged body take when trying to rotate on an inclined plane toward the bottom? That is what we are going to try to discuss for our today discussion. So when we learned when we was learned on the circular motion, we say that we get the linear acceleration by taking the linear velocity square, then we divide it by the radius. That is what we tried to see on our topic of circular motions. So when let us look for this topic. How can we get the linear acceleration for a rolling an object or for a rolling rigged board? We have told that we are supposed to consider the rigged board, and that rigged board have the radius and also the mass m. They are trying to roll down on an inclined plane. Now, how can we get the linear acceleration? That we have the rigged body. And that rigged body is placed on at the top of the inclined plane, trying to roll toward the bottom, downward toward the bottom. But it contains the mass. It contains the mass and also the radius, as we try to see. That rigged body which we are talking here is either the cylinder or the disc or the sphere, my dear students. So as we see our figure number 28 here, and our figure trying to explain the rigged body that is rotating with the axis of rotation along the inclined plane. We have the rigged body, and that rigged body rolling on an inclined plane. With on the inclined plane, it means along the inclined plane, only it is the axis of rotation. That is what we try to observe on our discussion here. So, my dear student, as we try to see here, we have the inclined plane, and this inclined plane involve it have the structure of the triangle, as we try to see. It involves the top. At the top here, it is allocated. It is labeled by the letter A. This is the top of the inclined plane, and also at the bottom of the inclined plane is labeled by the letter B, as we try to see here. But along the inclined plane, along to the A line AB and the horizontal, as we try to see here. We have the angle theta. This is the angle theta that is formed on the inclined plane. Now, this is the rigged body that we are talking. This is the rigged body. At the first time, it was allocated at the point at the top, at the point B. trying to roll downward toward the point B here, as we try to see. But this rigged body, my dear student, it can be dissolved so as to form either the horizontal force and also the force, the vertical force, or the force that is along to the inclined plane, as we try to observe. So when it roll, my dear student, it involves the linear acceleration. This is the linear acceleration. There are so many questions you will be asked that which many of those rigged body, either the sphere, the sphere, or the cylinder, or the disc, or the ring, can reach at the bottom fastly compared with the others. Here, in order to determine the rigged body that can reach at the bottom compared to each other, we could find the acceleration, or we could find the velocity, so that we can identify the speed of those objects. So we through this one, we can obtain the linear acceleration that on which the rigged body can take when it is trying to roll on an inclined plane. So as we see here, when this rigged body roll on inclined plane, my dear students, there are some forces here, the friction force that could oppose the direction, or could resist the direction of this rigged body, as we try to see here that there is the force here which is called the friction force, or sometimes we can say this is the resistance force that oppose the direction of this rigged body that is rolling on an inclined plane. So if we try to resolve here, by consider that this angle here, it is the same with the angle that is formed around to the vertical downward force, which is called the mg, and also there's forces. We could get it a horizontal force and also the vertical force. If we resolve here, we get that the horizontal force here, because it is the angle focus toward the horizontal one, toward this line, which is called the opposite. It can be equals to mg sine theta, and also the vertical, my dear student, could be equals to mg cos theta. This is what we can we try to see here. But as you can observe that this mg cos theta must be equals to Rn, and this Rn represent the normal reaction. This is not a new term for you, because when you was in form 2, in form 3, you tried to see the definition of the normal reaction, and also the definition of the friction force. This is the force that opposes or resists the direction of an object when it is in contact. So this rigged body rolling on inclined plane with an angular velocity. This W here could represent as the angular velocity. So what we observe here, my lovely students, is that at any instant, the line of contact AB with the plane is at rest. At any instant, that line of contact with the plane is at rest. As we try to see, at any instant, at any time, this line AB, which is is contact with the plane, is at rest. It means that there is no any object that is trying to roll on that inclined plane. Therefore, AB can be considered as the axis of rotation of the surface of the rigged body, because it's at rest. Now we can assume that line AB could be the axis of rotation, could be considered as the axis of rotation at the surface of the rigged body. This is what we can say here. So the component of weight acting along the inclined plane is this one. How can we get the weight that lie along the inclined plane? The weight that lie on the inclined plane, my dear student, on the line AB must be equals to the horizontal forces. This it can be represented by mg sine theta, as we try to observe here.